Hey, welcome. Today we're going to do more than just solve a math problem. We are going to crack it wide open and see exactly how to get every single mark. We're thinking like the examiner here.
So, here's the plan. We'll look at the puzzle, grab our tools, build the solution step by step, and then, this is the important part, we'll match it up with the examiner's mark scheme. Finally, we'll wrap up with what you really need to remember.
Okay, let's dive right in. Here's the puzzle we're going to take apart today. It's straight from a GCSE higher tier paper. Now, at first glance, this can look a little tricky, right? You've got algebra mixed in with your geometry, but don't let that letter E scare you. Honestly, the key to this whole thing is just knowing the basic rules of a parallelogram and putting them to work in the right sequence.
So, before we jump into solving this, we got to get our toolkit ready. And for this problem, our tools are the basic fundamental properties of parallelograms.
Okay, there are really just 4 key things you got to have in your head. First, opposite sides are parallel. Easy enough. Second, opposite angles are equal. Got it. Third, consecutive angles, the ones right next to each other, they always add up to 180 degrees. And finally, that classic one, alternate interior angles are equal. That's our whole toolkit right there.
All right, toolkit's ready. Let's start building our solution. We're going to go one logical step at a time, using the clues we've got and the rules we just went over. It's really just about connecting the dots.
So here's our game plan. It's a simple 4-step process that's going to walk us straight to the answer. It's clean, it's repeatable. Let's get started with step 1.
Okay, first tool out of the box, alternate interior angles. You've probably heard this called the Z-angle rule, and that's seriously the easiest way to spot it. See how the diagonal cuts across the parallel lines? It makes a Z shape. The angles tucked into the corners of that Z are always equal. This is our first big clue.
So, just by applying that one simple rule, we now know that angle ACD is also E. And just like that, boom, we've got the first piece of our puzzle. And hey, in an actual exam, that one little step, that's your first method mark. Right there.
Okay, so check this out. We now know both little parts of the angle at corner C. So to find the whole big angle BCD, all we have to do is add them up.
So, 3E plus E, that gives us 4E for the total angle BCD. See how this works? It's a perfect example of building a solution. We use one rule to find one small thing, and then we use that to find the next thing. It's like building with Legos.
All right, next tool from our kit. Remember this one? Consecutive angles in a parallelogram add up to 180 degrees. And consecutive is just a fancy word for angles that are neighbors, sitting right next to each other. This rule is what connects the angle we just found, BCD, to the one we're actually looking for, ABC.
And now we can finally build an equation. This is the moment where all that geometry detective work pays off. We're about to turn this shape problem into a super simple algebra problem.
So we just pop that 4E we found into our equation. That gives us angle ABC plus 4E equals 180. And from here, it's just a one-step bit of algebra to get our final answer. We're so close!
And there it is, our final expression. Angle ABC equals 180 minus 4E. We got there just by using the basic properties of a parallelogram. We followed the steps, we used the rules, and we landed on the answer. Nice!
Okay, so getting the right answer is awesome. But in an exam, what really matters is getting all the marks. So let's pull back the curtain and see how what we did lines up perfectly with an official mark scheme.
So take a look. This shows you exactly what an examiner is looking for. You get a method mark, an M1, just for finding that angle ACD equals E. Then you get a communication mark, a C1, for giving the right reason, saying alternate angles. And finally, you get that A1, the accuracy mark, for the correct final answer. Every single step we took has a purpose and gets you points.
So let's zoom out a bit. What's the big takeaway here? How can we use this same way of thinking for other problems, maybe even ones that aren't about geometry at all?
Really, what this whole thing shows is the power of having a structured approach. Don't just stare at the problem and panic. Break it down. Figure out what you know. List your rules. Build your argument one piece at a time. And crucially, show your work and state your reasons. If you follow that process, you don't just get the answer, you guarantee you get every single mark along the way.
Because at the end of the day, the goal isn't just to memorize how to solve this one problem, right? The real goal is to make this logical, step-by-step method second nature,
so you can walk into any exam and confidently tackle whatever puzzle they throw at you. Thanks for joining me.